Hello guys, welcome to AB Chemistry. Today we are going to look at one mnemonic device, thermodynamic box. This is the thermodynamic box you can see over here. So here, what this box using by memorizing only this box you can get around 20 more than 20 important equations which are asked in CSIR gate and other competitive examinations. So first of all, maybe you already know the parameters, so I'll just go through quickly. So this is volume, this is Helmholtz free energy, and temperature, Gibbs free energy, pressure, entropy, enthalpy, entropy, and internal energy. So here it is. Okay, so then you have to remember how to draw this, this mnemonic device. So to remember how to draw this, I used to remember like Vasu and Tippu hugged together. Vasu and Tippu hugged together. A hug. Okay, and a hug should be written like plus sign or a cross sign. Okay, so Vasu, V S T P, Tippu. Okay, and a hug, A H U and G, like this you can remember. And another thing you have to remind is whenever in all this set of equations, whenever we go upside, it is negative. You'll be getting a clearer idea when we use this. Okay, let's go to the first set of equations, that is Legendre transforms. Just these four equations, very simple equations, how to get this. So only thing is that you have to go like, if it is a box, we have to go from here through here and here. Okay, like this we have to go, or like that we can go like this, or like this, or like this, like many ways we can go. So by going these ways we can derive. So let's see an example like this. If you are going, so the equation is, we have to starting parameter, and we have to use plus or minus, and then in between parameters, and then n equals ending parameter. So here starting is this one, so I will change the color. So starting is this one. So here start plus or minus. So here, since we are going upside, as I said, since we are going upside, since we are like, I used to remember going hill is very difficult, so it is negative. So since we are going upside, it is negative and equals. So if you are writing this, u minus st equals a. I think this color is very sharp. I'll change the color. Yellow is good. Okay, so u minus st is equal to a. So thus we can get this equation, first equation. Going to the second equation. So similarly, before we go like this, right, similarly we can go like this also. Okay, remove this one. Okay, so just for understanding, we can go like this, start from here, start from u and end here. Okay, so again, if we put start is u plus or minus. So since we are going down, it is positive. Vp equals ending is h. Okay, I hope you understood. And similarly we can go another way also. So let's start from h. Okay, h, if we are going like this, so starting is h, since we are going up is difficult, so it is negative, st equals which is g. Okay, then going to the fourth equation. Here then you can choose maybe here vp equals g. Okay, a plus vp equals g. Okay, a plus vp is equal to g. So currently we have seen a plus vp equals g, and currently we have seen u minus st equals a, like this, like going like this. Okay, and if we go like this, u plus vp equals h, and going like, sorry, you will be getting confused, so going like this, we have seen h minus st is equal to g. Currently we have seen 4 of these equations. So next, if we go any other than these paths also, we can get the similar equations. So if we, let us say, like we start from g like this, if we are going, so g, since we are going up, it is negative, minus pv equals a. So as you can see, it is same as this one, only rearranging the equation. Okay, we have to just rearrange this equation and you'll get this. Similarly, if you are using any of these, all of these, only these 4 equations ultimately we will get. Okay, so thus you can, I hope you can write the Legendre transformation. So next is Maxwell's equation, these 4 equations. So how we can write this? So as you can see here, these parameters are not included, so we do not need that. Let us neglect. Okay, then how we can use, we should use like this. I think you do not understand, so we can look it like this. So just choose these parameters, vs these parameters like this. Okay, so this is the trend. So I'll start to write here. We'll start from here, right? Start from here and go here and end here. Start from here, go here and end here. Okay, so dou v, okay, by here it is s, so dou s, so whichever is in the end, it is at constant pressure. Okay, like here, if it is equal to, here it is t, so dou t, by here it is p, so dou p at constant entropy. So we get the first set of equation, which is same. Okay, as you can see, dou t by dou p at constant entropy is equal to dou v by dou s at constant pressure. Let's go to the second. So similarly, previously we have seen this one. Okay, now it is like this. Okay, so we'll start from here, go and end here. Start from here, go and end here. So starting is dou s by dou v at which is ending temperature. Next is dou p. This is dou p, and here dou t at ending is on v. So we get the second set of equations. Sorry, over here it is. second set of equations, that is dou S by dou V at constant temperature is equal to dou P by dou T at constant volume. Going to the third set of equations, like this we have to go. Okay, and since we are going like this, as you can see here we are going upside, so if you put negative we can put both here negative, so that will get cancelled out, so no need to put also, it's fine. So then here in this case we have to put negative because we start from here. If we start from here and like going upside, and here it is down, so okay. So since we are going from starting from S, going like this and up, we going like this and start. Okay, so let's start from S. So that is dou S by, here it is dou P at constant temperature, and since we are going up it is negative. I hope you understood, which is equal to, so here it is V, so dou V by, here it is T, so dou T at constant pressure. So dou S by dou P at a constant temperature and dou V by dou T at a constant pressure. So I hope you understood. Let's go to the next one. Okay, then next one is like this only. So similarly we have to put negative on one of this. So let us start from here. Okay, we start from here, go like end here. Okay, start from here, go like and end here. Okay, and dou T by dou V at constant entropy over here, and similarly here we start on P. So since this is going up, I'll put negative, and dou P by, here it is as dou S at constant volume V. So we can write dou T by dou V at constant entropy is equal to dou P by dou S at constant volume. Once you understand this concept, you don't need to write like this. We can just write the box and like think, you can think and write dou T by dou V at constant entropy is equal to, since this is up, so negative P by dou S at constant volume. It's very simple equation. Okay, so I hope you understood the four sets of Maxwell's equations. So we have looked onto the Legendre transforms and Maxwell's equation. Next we have to look onto the differential equations for U, F, H and G. So, and differential equations for U, F, H and G with variable amounts of matter. Let's look each of them. Okay, so here let us start with du. Okay, du. So here you have to find equation for U, A, G and H. So if whenever we ask du, we should start from the opposite side, and like this we have to go. We will understand in just a minute. So du is equal to, then we have to start from any of side you can start. So let's start from here, T ds, T, and next is d derivative of S, and since it is going down it was positive. Okay, and here it is going upside, so it is, then it is negative P, this P. Okay, then dv. Okay, I hope it's clear. Okay, and so this is the equation. So if you want with variable amounts of parameter, you can add this parameter also. Okay, then going to the next set is, if we write for dA, how can we write for dA? So I'll erase all of this. Okay, for DA we have to, like I said, we have to start from the opposite side and go like this and like this. Okay, DA is equal to, since in both sides we are going upside, minus, we can start from here, S dt, and again here also minus, since we are going up, P, this P, and dV. Okay, so we get the second derivative, this one. Similarly, we can write both other two derivatives like this. That is, if we write derivative of h is equal to, starting from the opposite side and going like this, start from the opposite side and going like this. Since both of these are downside, so it is positive, so v dp plus d ds. Okay, we get the second equation, and going to the third one is, fourth one is last one. First and last one is dg. You can go like this and this. Okay, v dp. Okay, since it is down, it is positive. Okay, and the second one is going upside, so it is negative, minus s dt. vdp minus s dt. So here it is, vdp minus s dt. Okay, so this is the differential equation for u, f, h and g with the variable amount of matters, and if without the variables also. The differential equation u, f, h and g is also asked in the CSIR many times. So next is that we have to compute the variables t, p, v and s. So these four sets. Okay, it's also very simple, I'll show you. Okay, so first we will start with t. Okay, t is equal to t is equal to, so we have to put equal to like this. Since you are going down, it is positive, so, and like this. Okay, you'll understand in a minute. So here it is h. Oh, I don't need this. Okay, here it is h, so it is dou h, and here it is s by dou s at constant. So next to h, what it is, you have to check, it is pressure P at constant pressure, which is equal to, also here also you can write like similarly, dou u by dou s at constant. Here it is volume. So you can get the first equation like this. Okay, going to the second equation. Going to the second equation, maybe I'll erase here itself. So let's first equation stay here. Okay, and going to second equation is for, I think, for v. Okay, v equals, so we have to put equals like this and then like this only. Okay, so v equals, here also we are going downside, so it is positive, so we'll start from here. Here it is h, so dou h by dou p at constant, which is next to h, so it is entropy s. Okay, and similarly here it is g, so dou g by dou p, which is next to g, we have to check, that is t. So we get the next equation, which is this. Okay, and going to the next one is for p is equal to, so So again we have to put P is equal to like this. So here it is going upside, so it will be negative. So better to write a negative over here, otherwise you can put both the variables negative also. Okay, so equals to, all other things are same. So dou U by dou V at constant entropy also equals to dou A by dou V at constant, which is next to A, temperature. Okay, okay, also you can put both of this negative, or either you can put negative here. Okay, and going to the fourth and the last one over here, you put negative is over here. So S equals like this and this, S dou G, since it is going up, we can put negative over here. Dou G by dou T at constant pressure is equals dou A by dou T at constant, which is next to it is volume. Okay, similarly okay, here you can see the equation over here. Okay, so like that you can derive all the equations to compute the variables T, P, V and S. Then I think we have completed Legendre transforms, equation to compute variables, and differential equations for U, F, H and G, Maxwell's equations, and this also. Next is we have also calculate the spontaneity criteria also for the spontaneity criteria for a reaction to perform. For that it is very simple. This also I have seen many times asking in CSIR examinations also. So it is the 4 criteria. So whenever you can use these 4 parameters, and these are main things for the spontaneity criteria. I'll show how it is used. So let's start from du. So du is, we have to check which is next to du. So at constant entropy and volume less than or equal to 0 is one of the criteria. And okay, similarly you can write also for H. So H is dH, which is next to H is S and P. So at constant S and P is less than or equal to 0. And similarly we can write for Tg at constant temperature and pressure, okay, is less than or equal to 0. And also you can write for A also, okay, dA at constant volume and temperature is less than or equal to 0. And these are the 4 main. And again also for entropy, it should be greater, these values should be negative. As you may know, these values should be negative for a reaction to be spontaneous. For entropy it should be positive. So that is entropy. Yes, so ds, here you have to check these two. Okay, ds at a constant energy and volume is greater than or equal to, you have to check the sign. The sign is opposite. Okay, greater than or equal to 0. And also here this parameter also, ds at constant enthalpy and pressure is greater than or equal to 0. Okay, I hope you understood all of this. First we have to write each set of these equations a du dA du dH and dG, and then you have to write the quantity criteria of this comparing with these two. Okay, I hope you have understood the spontaneity criteria. Similarly, you can also get for chemical potential also. So for chemical potential, similarly we can write that is for dou G by dou Ni at constant which is next to T and P, P and Nj. This is Ni and Nj equal to okay. And similarly you can write all of this like this. So sorry, next maybe I can use, so maybe dou U by dou Ni, just check which is next to U, that is S and V Nj is equal to okay, and then dou A by dou Ni at, so here it is V and T J, sorry, Nj is equal to okay. And similarly the last one will be dou H by dou Ni at constant, here it is S and P, Sp into Nj. Okay, I hope you understood all of these well. Okay, so I hope you understood all of this as well. So if you have any doubt, please let me know, and thank you. Don't forget to subscribe this channel and share it with your friends. Thank you.